LMS Imagine Lab AIM 14 brings many advanced features to strongly support model-based systems engineering for the aerospace and defense industries. Innovative multi-domain libraries, application-oriented solutions, ease of use for seamless deployment, as well as support of system-driven product development are some of the numerous value brought by LMS Imagine Lab AIM 14. Starting with the new transverse functionalities released in the physical libraries, the 3D mechanical library is enhanced with new mechanical junctions, and all junctions were improved to be explicit, allowing for generating CPU-efficient and real-time compatible multi-domain models, such as landing gear with actuation and braking systems. I would like to highlight also the improvement of the thermal fluid libraries with the capability to represent the variation of gas content into the liquid along the fluid network, as well as the representation of the dynamics of aeration and gas dissolution, providing a great degree of model refinement for detailed design of high-frequency thermal fluid systems through the aircraft. And since CPU time of the full thermal fluid systems might increase, we now release the capability to partition the model using the new discrete partitioning capability with LMS AIM 14. I would like to highlight also the new capability to represent the transport of liquid condensate droplets in the gas mixture library, especially of interest for the environmental and control systems performance modeling. With LMS AIM 14, we also have improved the capability to model and simulate advanced aerospace and defense subsystems, focusing on their key attributes. I will highlight 3 applications in which major progresses have been made. The first application is the aircraft fuel system, where the new 3D modeling assistant greatly enhances the usability of the solution by automatically creating the 3D scene with a bidirectional parameter update to and from the model, providing the animation of results and allowing for 3D object import. The user will more rapidly and easily model and analyze the system's behavior. In addition, the variation of altitude and acceleration of the aircraft is now accounted for in the fluid pipes to size the fluid components and validate critical design cases during fast maneuvers, such as rejected takeoff. The second application is flight dynamics, with new aircraft body models accounting for aerodynamic loads, as well as the environmental settings, such as the effect of round Earth assumptions on the flight missions. This capability allows for simulating the full aircraft and its subsystems over its full mission, or a particular maneuver, to correctly account for the variation of the environment, such as the altitude, the atmospheric pressure and temperature, the aircraft acceleration. That is for the design and validation purposes. The third application is the propulsion system modeling, where LMS AIM 14 brings new jet engine models for various architectures to allow for the fuel consumption analysis as well as the thermodynamic analysis for pre-design of propulsion system at aircraft level over the flight missions. In addition, the new propeller performance map generation tool, based on the propeller geometry and airfoil, allows for more refined design of propeller propulsion system, considering aerodynamics performance and accurate effort computation on the blade for designing systems such as pitch actuation systems. To ease the daily work of systems engineers, it is also essential to rely on a strong simulation platform, supporting this multi-domains application in a model-based systems engineering context. LMS Imagine Lab AIM 14 is exactly this. It is easier to use, open, scalable in terms of physics and applications, and also supports collaborative works. This release emphasizes on strong solver numerical capabilities coupled to powerful analysis tools like the CFD1D with multi-thread technology, like the completion of the performance analyzer, also the algebraic loop highlighting, making the user work easier and more efficient. A strong focus has been put on the openness with extended plot APIs, with more capabilities towards modeling in the loop, software in the loop, hardware in the loop, and real-time simulation, with the possibility to sense internal variables of components and use them for control purpose. LMS Imagine Lab 14 also integrates the FMI 2.0 support with the FMI GUI integration. It also benefits from an improved support of the Modelica specification with the new event handling feature allowing for LMS AIM-Sim 14 to support a large number of the Modelica standard libraries. Finally, the 14 release is oriented towards usability, with new capabilities for CAD file import-export in support of modeling operations, with CAD measurements and property calculation, but also with enhancements of the App Designer tool for users to create their own pre- and post-processing apps on their models. And finally, with the State Chart Designer completion for easier representation of driving scenarios and for logic controls design. These were a selection of new features and capabilities of LMS Imagine Lab AIM-Sim 14. For deeper insight, please visit our website.